Hello, my name is John Benedict, and this is a replay of the presentation that I gave at Red Hat Summit 2017 in Boston. This is deploying a highly available Red Hat Virtualization Manager, the self-hosted engine configuration for Red Hat Virtualization. The agenda for this presentation is very simple. We will go through describing what is self-hosted engine in comparison to the other deployment options for Red Hat Virtualization Manager. We'll go through the deployment walkthrough, and then there are some pre-recorded demos to show you the installation, the configuration, and the failover demonstration. So what is self-hosted engine? Engine itself is synonymous with Red Hat Virtualization Manager. Anytime you hear someone from Red Hat support or Red Hat engineering talk about engine, they are in fact talking about Red Hat Virtualization Manager. Self-hosted engine is also referred to hosted engine, or HE for short. In a hosted engine environment, Red Hat Virtualization Manager runs as a virtualized appliance on a Red Hat Virtualization host or Red Hat Enterprise Linux server. So why consider it as an option? First and foremost, RHV-M provides HA, high availability for RHV-M. It reduces the overall footprint of Rev in that you don't need RHV-M to run natively on a separate host. You don't need RHV-M to run as a VM on a separate RHEL and KVM deployment. And it also means that you need fewer overall hypervisors in the environment. And because it runs as a virtualized appliance, it reduces the overall steps needed to not only deploy Rev, but also reduces the overall operational needs to manage Rev. So what happens if RHV-M goes down? Why would someone need to consider running RHV-M in a highly available configuration? In essence, RHV-M is the brains of the operation. Without access to RHV-M, there is no access to manage the resources from an administrative standpoint. You cannot get to the compute, network, or storage resources. Admins can't get to it. Users can't get to it. That also means that none of the integration points are accessible. So the REST API from CloudForms, none of the integration points from Ansible or anything else, third-party tools. So backup, recovery, reporting, automation, none of that is available. But it also means that there's no providing of service to those virtualized resources. So if you have virtual machines that go down that require highly available resources themselves to be restarted on other hosts, load balancing, optimization, user quotas, quality of service, none of those things that RHV-M provides will be available. However, anything else that runs behind the scenes, so the virtual machines themselves, will still be up and running. So that will still be going. It's not like the entire environment goes down, but it's still very important that RHV-M maintains that service level. So you want RHV-M to come back up as soon as possible if should something happen. So the configuration options. There are three primary deployment methods. There is the standard deployment method. This is non-highly available. So that would be running RHV-M as a native application on bare metal, or running RHV-M as a virtual machine in another virtualization environment, in another deployment on a RHEL with KVM environment, or running RHV-M in hosted engine with RHEL, or running hosted engine with the Red Hat Virtualization host. And that last option is what we're going to focus on today in terms of the demos. So the standard RHV-M deployment, that's what we're looking at here. You have a couple of clusters and a data center on the right, and you have RHV-M running natively on a host. There is no high availability, and it's fairly straightforward to set up. Now the workflow for this, it's not complicated, but when you compare it to the hosted engine configuration, there are a few more steps. You set up the RHEL host, you deploy the environment, you install RHEL, you update that system, then you have to download the RPMs, install Cockpit, you launch the installer, and you go through the actual deployment of Red Hat Virtualization Manager and the environment itself. Comparing RHV-M on bare metal to RHV-M as a virtual machine, as a virtual appliance in the hosted engine configuration, you don't have any of the mobility that you get when you have RHV-M as a virtual machine. So underlying host needs maintenance or lease return. Any of the good reasons that you would deploy any application as a virtual machine or appliance. Self-hosted engine, again, the big reason here is being able to have a highly available configuration. RHV-M is able to start up on another host in the hosted engine cluster should something happen, so that all of your other service level agreements, REST APIs, all of your other service level agreements go on. The workflow for self-hosted engine is more condensed. RHV-M and the virtual machine itself are deployed almost as one single step. You deploy the environment, you install the Red Hat Virtualization host, you push the RHV-M appliance. When you launch the installer and answer the questions as part of the install process, it will actually deploy the VM and RHV-M as one single process, so that when it comes up, you log into RHV-M, and then you just when you log into RHV-M, you simply finish the configuration process. It's a much simpler workflow for deploying self-hosted engine. So deployment options. When you look at considering standard deployment and self-hosted engine, I want to be clear here. When we talk about pros and cons, we're not talking about one is better or worse than the other. We still want to consider that the use case, the overall use case, is what ultimately determines what is better for your particular environment. For example, when looking at a standard deployment, it is very good for a lab environment. It's very easy to customize in that if you have a requirement for customizing how RHV-M is actually laid out in terms of file systems, customizing how the different subsystems are put together, if you need to break out the web proxy from the database and things like that, then the standard deployment is much better suited for that. The cons on the standard deployment is there is no high availability for that. But if you don't need high availability, it's not necessarily a con. Hosted engine. Obviously, high availability for RHV-M is probably the biggest pro. But again, it's a reduced hardware footprint. There is less to manage. The cons, it's not as easy to separate components. But again, if you're not looking to separate components out like a separate web proxy, it's not necessarily a con. When we look at comparing whether or not you want to deploy self-hosted engine on RHEL or the Red Hat Virtualization host, again, we're looking at use cases here. It's not that one is better or worse than the other. Again, we're looking at use cases here. The pros, the ability to customize for security or business needs for the Red Hat Enterprise Linux host. For example, if you need to set up the file system in a particular way, then it's easier to do that with the Red Hat Enterprise Linux host. The cons are it's not as purpose-built as the Red Hat Virtualization host. For the Red Hat Virtualization host, it is in fact an appliance approach to the host. It matches up very well with the Red Hat Virtualization Manager appliance in that there is less to manage, there's less to deploy. When you update the Red Hat Virtualization host, you are not managing and updating individual packages. You are updating and managing a single image. The cons are that you have to stick with the LVM thin pools, which again, if you're okay with that, then it's not necessarily a con. Requirements. It's very similar comparing the RHEL based to the Red Hat Virtualization host based. For the RHEL based, you need a new install. You don't want to go with something that's already been deployed that potentially has some configuration artifacts. You need the hosted engine virtualization appliance version 7.3. You need storage already ready to go for RHV-M. You need to have a fully qualified domain name for Red Hat Virtualization Manager. NTP is not required, but it is highly recommended for all of the hosts and for RHV-M. And you need to have 5 gigs of storage ready in var, and that is for the OVA image for the virtualization appliance, for the RHV-M appliance to expand. And you need to have the overt hosted engine and screen packages ready to go as well. For the Red Hat Virtualization host based deployment, again, you need a Red Hat Virtualization host 7.3 new install ready to go. You need that 7.3 version appliance. You need storage deployed not only for RHV-M, but you need a separate storage deployed for the hosted engine. You're going to have, in most instances, you're going to have separate storage for the hosted engine data center and the RHV-M production data center. The one difference there is if you're only going to have if you're going to have a very small deployment, say a 2 or 3 node deployment, and that's all you're going to have, you can get away with one storage domain. But if you're going to have, say, 10, 15, 20 nodes, you want to keep a separate storage domain just for hosted engine. You must have fully qualified domain names for RHV-M and for your hosts. If you do not have a fully qualified domain name for RHV-M that includes forward and reverse DNS lookups, then the deployment will fail. Again, NTP is not required, but it is highly, highly recommended. And then just like in the RHEL based, you need 5 gigs of storage and ready to go in var. Best practices. Read and follow the install documentation. It is good stuff. You don't need to necessarily read it cover to cover, but you want to go over the requirements because there may be changes between the time that you read and see this presentation and the time that you go to deploy your environment. There is good information in there. There is a separate install document for hosted engine as compared to the regular standard deployment for Rev. You want to make sure that you go through that. Look at the requirements for the Red Hat Virtualization host deployment versus the RHEL deployment, and then go through and just kind of skim through the rest of the information. There is good information there. Do not skip that step. Make sure that the rest of your environment is ready to go. Make sure your networks are good. Make sure that your storage is ready to go. Make sure that your servers are racked and ready to go. NTP, DNS, and fully qualified domain names. Have all of that information ready to go. You want to make sure that it's all on hand so that you can either type it in or copy and paste it and ready to go. Because when you start that, the deployment steps, you want to make sure that you are able to just type that in and ready to go. It'll make the deployment steps that much easier. It'll make the deployment that much faster. You also want to make sure that the other pieces in the environment are redundant and highly available. Switches, HBAs, network cards, the power, so on and so forth. It doesn't make sense to make RHV-M highly available if the other components in the environment do not match suit. And then document the environment. Make sure that everyone understands how the failover process works. Make sure that everyone understands how the failback process works. Make sure that everything is documented top to bottom, all of the IP information, all of the hosts. You want to make sure that everything is there, not only from a digital standpoint, online documentation, but make sure that once it's uploaded, that every once in a while you print off a PDF version, because if you can't get online to read that documentation, that you have a printed copy somewhere that you can reference. Directory services. Directory services are not required for Rev, but they do make certain operations a lot easier. RBAC services are a big one for extending user capabilities and admin capabilities. And then integrating with Red Hat Satellite. Again, not a requirement, but it does make managing those software life cycles for both host and virtual machines a lot easier. I do not recommend you having local users on the hosts, operators only, operators and admins only on the hosts. And then standardize the hardware as much as possible, especially on the hosted engine cluster itself. If you have to have a mix and match elsewhere in the data center, I understand, but at least have the same make and model and configuration of hosts in the hosted engine cluster itself. So the deployment walkthrough, what does that look like? For the Red Hat Virtualization host, very straightforward. You deploy the Red Hat Virtualization host, and then the Rev image itself. There's actually a couple different points at which you can deploy the Rev-M image. Once you subscribe the Red Hat Virtualization host to the Red Hat Content Delivery Network, you can pull down the Rev image at that time manually. You can pull down that image to another host and copy it over to the Red Hat Virtualization host. Or once you start deploying hosted engine, that deploy process will pull it down automatically. Personally, I like to actually pull it down as part of the subscription process. So deploy RevH, subscribe to the CDN, and then pull down the Rev-M image at that time. Pay special attention to the disk layout, making sure that you have 5 gigs in VAR so that you have enough space for the OVA image to expand, and then make sure that you are only using LVM thin pools. If you let RevH deploy the file system for you, that's not going to be a problem. But if you go in and change the file system layout on your own, then you have to manually choose LVM thin pools. Subscribe things to the Red Hat CDN. Subscribe your hosts to the Red Hat CDN or to Red Hat Satellite if you have that. And I already talked about installing the Rev-M appliance. Once the Red Hat Virtualization host is deployed, log into the Cockpit host administration tool. That's opening up a web browser and going to secure HTTP. Use the host name port 9090, and then select the TuneD virtualization host profile. Launch the hosted engine installer, and then answer the prompts for the IP information, fully qualified domain name, so on and so forth. And watch for the VNC information, because at that point you'll be able to watch the host deployment. At that point you'll be able to watch the deployment process for hosted engine. We'll actually be able to see all of this in one of the recorded demos. And then we'll finalize the configuration. Once the deployment is complete, we'll log into Rev-M. We'll add the VM storage, which triggers the finalization of the hosted engine configuration. Once that's done, the hosted engine storage appears, the hosted engine VM appears, and at that point we can add the additional host so that the hosted engine virtual machine actually has somewhere to fail over to, and then we can actually test the failover. So final testing for your environment, and this is, I can't recommend this enough. This is really important. You want to make sure that you do this once your deployment is done, but before you go through and actually try and add production hosts and add production VMs to the environment. If you can actually log into Rev-M, that's a big deal, because that means that all of the web proxies are done, that JBoss EAP is installed correctly. If you can finish the configuration, the storage, adding the host, that means that Rev-M can actually go out and talk to all of the different pieces that it's supposed to. Will Rev-M live migrate from host to host? That is also a big deal, because that means that the other subsystems for Rev-M are working properly. And then the command line hosted engine --VM status. If it provides positive results, where it shows that that the VM is running on one host but not on another, that is also a good sign. We'll actually use that command in one of the recorded demos. And then does RHV-M automatically restart when failure is caused? That's the big test. So if it restarts when failure is caused, and does it live migrate? Those are the big points. So now we'll look at the recorded demos. So what are we going to see? We're going to build the Red Hat Virtualization host. We'll launch the install. We're going to add an additional host. We'll test the live migration, and we'll test the failover. So in this first demo, we're just going to show the difference between deploying this for RHV-M versus a standard deployment. And we're just going to do the custom disk layout just so that we can show you the LVM thin provisioning. You can see here when you do the drop down, you can see the LVM thin provisioning here. This is what's critical. If you allow it to do the disk layout for you, you don't have to worry about this. But if you change anything in the disk layout, you have to do LVM thin provisioning. You don't need a whole lot in terms of disk layout because it is in fact in appliance. Now, once it's done, we use the Cockpit host administration tool. We log in using the root login. And then we'll just use the console to install the RHV-M appliance. Pulls this down, and we'll just speed things up a little bit. We see that it's subscribed. And then we're going to adjust the performance profile. This is the TuneD profile that I spoke of earlier. We scroll down, we change this to a virtual host tuning profile. No reboot is necessary. And that's all the configuration we need to do there. Now in the second demo, we show that we have forward and reverse DNS. Remember, I stressed that it's very important to have forward and reverse lookup. Now we're going to go to the virtualization tab, and we go to the hosted engine, and from here we're able to launch the hosted engine setup. From here, it's just a matter of plugging in all of the values. This is where it's important to have all of our IP information, fully qualified domain name information, all of our NFS information ready to go. Now here I've used almost all default values. I believe the only non-default value that I used here was for the IP information for the RHV-M appliance itself. I chose not to do DHCP, I chose to use static IP information. Here's where I changed DHCP to static. Obviously, I've sped things up to kind of move things along. You can slow this down or hit pause at any point. Here's where you can go back through and confirm all of your information. Now here you see the welcome to health status, acquiring CA cert. That means that things have moved along quite well, depending on how fast your system is. Here, this is where I flip things over to the VNC, where I can see what's going on with the host itself. Once it posts the VNC information, you're able to look at what's going on with the host itself. Now, typically, the VM, if you do need to reboot the VM for any reason, it goes pretty quickly. But the initial configuration and the initial reboot of the host does take a few minutes, so don't let that concern you in any way. So here you're going to see that there's not a whole lot of information here. This top line says the hosted engine storage domain doesn't exist. It will be imported automatically upon data center activation, which requires adding a storage domain to the data center. That's what we're doing right now. We're adding in our data domain for our virtual machines. Once this is initialized, we're going to be able to see everything else that we've configured up to this point. So once this is initialized, now we see the hosted engine storage domain pop up. And once that is done initializing, we'll be able to see the hosted engine virtual machine. So there's the virtual machine itself. It's got the address that we applied to it earlier. And the dashboard has been updated as well. Now we can add in our other hosts so that the virtual machine has somewhere to fail over to. And here we hit the deploy option so that the additional HA components are added to the host. Now you see the gold crown next to the first host and the silver crown next to the second host. That simply means that the gold crown simply means that he has the hosted engine virtual machine, and the silver crown says that he's waiting in the wings should something happen. In this last demo, we're going to show the actual failover. We see that RHV-M is running on the second host, but we're going to introduce some failure to the data center in the form of some fire, some explosions, and giving badge access to a velociraptor. We can see that now we don't have access to RHV-M because we've pulled power to the second controller. But how do we confirm that the RHV-M appliance has failed over? We open up a console to the other controller, and we can see that the health is good, the engine status is good on the other controller. We see that the engine status is unknown on the original controller. So now we hit close on the operation canceled window, we refresh the browser, and we log back into the host. And we see that the gold crown has moved back to the second host. Wrapping up. So what do I gain from using hosted engine? Well, first and foremost, high availability greatly reduces the interruptions that failure introduces to administrative access. After all, RHV-M is the primary access point for managing compute, network, storage, users, and other pieces of the virtualization environment. but it also means that we provide continued access to the REST API, so backup, recovery, reporting, automation, and other integration points. But it also means that the SLAs that we need to provide to the virtual resources, so load balancing, quality of service, quotas, and the high availability to the virtual machines, are also maintained or at least restored very quickly. But a hosted engine also reduces the overall deployment time for Rev, the operational needs for Rev, and the hardware needs for Rev. So if you need additional information for Hosted Engine, highly recommend that you go to docs.redhat.com and see the Hosted Engine installation guide. Both links are right there on the page. Thank you very much.